Today we are going to learn what is a clamper circuit and its function. A clamper circuit is a circuit that consists of a diode, a resistor and a capacitor, and it shifts a waveform to a different DC level without changing the shape of the applied signal. The clamper circuit is of two types. One is positive clamper circuit and the other is negative clamper circuit. The positive clamper circuit shifts the applied signal to a higher DC level, and the negative clamper circuit lowers the applied signal. Now suppose our input signal is this and V in is Vm sin omega t. Now when this signal is passed through a positive clamper circuit, the output would be something like this. Say this is V dash and the output will be like this. And when this signal is put across a negative clamper circuit, the output will be something like this. Say this is minus V dash, so it will be like this. Now let us see what is the function of a positive clamper circuit. The circuit is like this. Here is a capacitor, a diode here, a resistor is connected in parallel to the diode, and this is the output. Here we are giving the input signal V in, this is VO, this is the resistance R, D here, the diode and the capacitor. Now our applied signal being this, we can say from 0 to t/2 this was positive, and from t/2 to t the signal is negative. Now we will analyze the behavior of the circuit at different time ranges. First, from 0 to t/4, in this time range the equivalent circuit is this. The positive part of the implied signal is connected to the N side and the negative part is connected to the P side. That means the diode is in reverse bias, and hence we can replace the diode with an open circuit. Now the input that is given here, V in, will be across this RL also, and hence VO should be V in. Now before this connection was made, the capacitor voltage was 0, and we know the capacitor prevents any abrupt change in voltage. So after this connection also, till the capacitor is charged, the voltage of the capacitor will remain as 0. So in this time range, the values of VO and VC are this. Next, in the time range from t/4 to t/2, in this time range also our VC is at 0, and since the diode is still in reverse bias, our V output will also be same as in the first case, that is V in. Next, from t/2 to 3t/4. Now in this time range, for the first time the diode becomes in forward bias, and our equivalent circuit is this, because the diode is replaced by a short circuit. as it is in forward bias. So this is our equivalent circuit. Now the resistor will also get short circuited, and hence our equivalent circuit is actually this. This is the V output, this is V in. Now you see here is no discharging element in the circuit except the capacitor. So the capacitor will be get charged due to this V in this direction. Now this charging will take 0 time, because we know that the charging or discharging time for a capacitor is tau equals to RC, where R is the resistance of the resistor connected in parallel to the capacitor. Here it is 0, so tau value is 0. So the capacitor will be charged to the peak value of the input voltage, that is to Vm, in no time. Now in this scenario, our VO will be what? The voltage across the resistor R, and here R value is 0, so VO value will be 0. So in the time range from Ty2 to 3t upon 4, the value of VO is 0 and Vc is Vm. Just after 3t by 4, that is at 3t by 4 plus, the value of Vc will be equal to the value of Vc at 3t by 4, because we know capacitor prevents abrupt change in voltage, but VO will change. Now at this point our equivalent circuit is having a voltage source of Vm here. The capacitor will work as a voltage source, the diode is here, the resistance here, and this is this Vn. Now one can say that the diode is in forward bias, but here we have to determine what is actually happening with the diode, because here is an additional voltage source of Vm here. So let us see what is actually happening with the diode. Let's put KVL law in this mesh. So minus V in plus Vm plus Vd is equals to 0, that is Vd is equals to V in minus Vm. Now from the circuit I have drawn before, it's clear that Vd should be positive, so that the polarity of the diode doesn't change and the diode remains in forward bias. So the condition for forward bias is V in minus Vm greater than 0, that is V in is greater than Vm. Now our input is this, or V in's maximum value can be Vm. So this condition for the forward biasing of the diode doesn't hold, and hence the diode will not be in forward bias anymore after 3t upon 4. After 3t upon 4 it will be reverse biased. So the equivalent circuit will be this. The VO is here, Vm and V in, and applying KVL law we can say VO is V in plus Vm. Now we will deduce various values of VO at different time instants. So let us start. VO at 3t upon 4 will be Vm into 1 plus sine 3 pi upon 2. This is 0 because sine 3 pi upon 2 is minus 1. VO at t equals to Vm sine omega t plus Vm, that is this is equals to sine 2 pi, and the whole value becomes 0, so it is Vm. VO at 5t upon 4 will be Vm into 1 plus sine 5 pi upon 2. Sine 5 pi upon 2 is 1, so the value will be 2 Vm. VO at 3t upon 2 will be Vm into 1 plus sine 3 pi, that is Vm. VO at 7t upon 4 will be Vm 1 plus sine 7 pi upon 2. Sine 7 pi upon 2 is minus 1, so this is 0. And VO at 2t will be Vm into 1 plus sine 4 pi, that is equals to Vm. All these values implies that after 3t by 4 there is no negative value of output voltage, that is after the time instant the applied signal is positively clamped. Now these values will be helpful for drawing the output graph. So let us draw the graph. This side we are taking T and this side VO. Suppose this is our Vm and this is 2 Vm. Let us divide the time axis with duration of T by 4. Our input is like this. Okay, now from 0 to T by 2 the VO followed Vin, then it was 0 till 3t by 4, then it followed Vin again, then it went to 2 Vm, then to Vm, then 0, then to Vm and 2 Vm, like this. At this point if we analyze with this was 0 and here it is Vm. The signal is same, the shape is same, only difference is the DC level, which is shifted upward by Vm, and so we can say that this is a positive clamper circuit. So thanks for watching the video. If it was helpful for you, then please share this video with your friends and also like the video and also subscribe our channel. Thank you.